Welcome back to another video with Rise Up, Don't Run Math. In this video, we're going to focus on finding the distance between points on the coordinate plane, and then we're going to transition to how do we find the distance between points when the graph isn't given to us. So let's go ahead and start by reviewing how we would find the distance of points on the coordinate plane. It wants us to find the distance between the points 10, 1 and -4, 9. Those points have already been plotted and the length between them has been drawn. So, as a review, what we've learned previously is that we can utilize Pythagorean Theorem to find lengths when they're plotted on an xy axis. To do that, we're going to start by drawing a right triangle. If we think about dropping our point down until it's at the same height as our other point, and then going across, we can create this right triangle. By the way, you don't always have to go down. If you wanted, you of course could instead go across this way and then down. It doesn't really matter which way you choose. Let's go ahead and use that second way. So, if I go ahead and start by counting how many units I went across, I can see that I went across 14 units. And I went down 8 units. However, the down part doesn't really matter because I'm thinking about distance, and distance is always considered to be positive. Now I can use Pythagorean Theorem to find my third length. As a reminder, the side that is across from the right angle is always what we call our hypotenuse. I'm going to abbreviate it HYP, and it takes on the value of c in the equation a squared plus b squared equals c squared. 14 and 8 are going to take the place of a or b. It doesn't matter which one since they're both getting squared and then they're getting added together. So I'll go ahead and do 14 squared plus 8 squared equals c squared. 14 squared gives me 196 and 8 squared gives me 64. When I add those two values together, I get 260. And that is still equal to c squared. To solve for c, I would take the square root of both sides, and the square root of c equals c equals the square root of 260. From here, I can either choose to approximate my distance or to simplify the radical. I'll go ahead and do both. 260, we want to see if there is a perfect square that goes into 260. There is, and the perfect square is 4. 4 times 65 gives me 260, which I can then break apart into two separate radicals. The square root of 4 is 2 times the square root of 65. This would be my exact answer in most simplified form. If I wanted to approximate c, I would simply do the square root of 260 on my calculator, which gives me approximately 16.125. If you didn't remember how to simplify radicals, go ahead and look back at one of the previous videos on my channel. Let's go ahead now and think about how we could transition this into being able to think about finding the distance when the graph isn't given to us. To do this, let's think about where the numbers 14 and 8 came from. 14 came from thinking about how much my graph changed by on my x-axis from left to right. So this is my x-axis. So this is my change in x. You may recognize this symbol from algebra, delta x. Delta just means the change in x. On my y-axis, I found that the change in y from top to bottom, it changed by 8 units. That's my change in y. Find the change in y and change in x without having to use our graph. To do this, I have a particular strategy that I like where we're going to go ahead and stack the points on top of one another, almost as though they're in a table. So we have the point 10, 1, and we have the point -4, 9. As a reminder, the value that is our x value is the first value in our ordered pair, and the value that is the y value is our second value in our ordered pair. So what I want to start by doing is thinking about how did this change when I found my change in x. Some of you may be able to count this. For instance, you may know that going from 10 to 0 would be 10 units, and from 0 to -4 would be 4 units. So in total, it would have changed by 10 plus 4, which is 14. However, since it went down, I'm going to write -14. I can do something similar for thinking about how did my y value change. So this here is going to be my change in y. So it went from 1 to 9. Many of you could probably do this by counting. It added 8. If sometimes you have tricky numbers and the counting is difficult, we can think about it as subtraction to find their difference. Sometimes students prefer this when there are negative numbers and it becomes more difficult to count their difference. So to find their difference, we would think about doing, let's start with the x, x2 minus x1. You've seen this before when you're using slope to find how much they change by. We're doing the same process here, but instead we're using it to think about it to find the distance of the diagonal. x2 is going to be the point that we wrote second. So this here is going to be our x2, and this will be our x1. So I'm going to do -4 minus 10, which is -14. I can do something similar to find my change in y. I would now do y2 minus y1. The point that I wrote second would be y2, and the point I had first would be y1. y2 was 9 and y1 was 1, so when I subtract, I get 8. Notice that I have 14 and 8 in our original Pythagorean theorem we set up. Here we have -14 and 8 because we did take into consideration the direction. The negative isn't going to matter when I square it because a negative times a negative will become a positive. So using this, we would be able to say -14 squared plus 8 squared equals c squared. And when we'd solve, we'd get the same answer that we got previously. Let's go ahead and take a look at an example that doesn't have the graph given to us. In example 2, they want us to determine the distance between the points -5, 6 and 8, -4. Once again, I prefer to start by writing my points over top of one another. -5, 6 and 8, -4. We're going to be thinking about what is our change in x. This is our change in x. And then what is our change in y? This side would be our change in y. If you're good with going between negative and positive numbers, you can count these changes. I would encourage you to do that if you're able. However, if you may be struggling to count the difference between -5 and 8, we can think about doing x2 minus x1 to find their difference. Remember, the difference between our second value is what we're going to consider our x2, and this will be our x1. So 8 minus -5. The minus and negative becomes a plus, which gives us 13. If you did this with counting, you may have noticed that from -5 to 0 would be +5, and 0 to 8 would be +8. 5 plus 8 gives us that 13. We can do the same thing for our change in y. We can do y2 minus y1, which is -4 minus 6, which is -10. If you did it by counting, to go from 6, I always use this like 0 point in the middle. So from 6 to 0 was -6. From 0 to 4, -4 was -4. So in total, it went down by -10. From here, we can use these values as our a and b when we use Pythagorean theorem. So just to visualize this, even though we haven't drawn it, this is the distance we're trying to find. Our x changed by 13, and our y changed by -10. So now we can fill into Pythagorean theorem. We have -10 squared plus 13 squared equals c squared. Whenever you're squaring a negative number, you need to write the negative number in parentheses to show that the negative is also getting squared and not just the 10. Negative 10 times negative 10 is 100. 13 times 13 is 169, which equals c squared. When we combine 100 and 169, we get 269 equals c squared, and then we can take the square root of both sides. We should always try and simplify our radical if we can. In this case, 269 cannot be simplified. If it helps you to visualize an approximation for what this number would be if we were to round it, this is approximately 16.401 units long. I hope this video has helped you realize how you can find the distance between points on the coordinate plane when the coordinate plane is not provided by utilizing Pythagorean Theorem. Thanks again for tuning in to another video with Rise Up, Don't Run Math.